Today, we are taking the fear completely out of the command line
Oh, yeah, totally.
because our mission for this deep dive is to take a piece of software that's just trapped on your local laptop, and we're going to deploy it live to the internet.
Which is, a huge milestone.
It really is. And to figure out how this is actually done, we are pulling from a massive stack of technical documentation today.
A very dense stack, I might add.
Right. We've got DigitalOcean tutorials on Linux infrastructure and SSH. We've got GitHub's official deployment documentation, PM2 quick start guides, the Linux Foundation's breakdown of file system permissions, and of course those community TLDR command pages.
Which are lifesavers, honestly.
Oh, absolutely. And we're going to synthesize all of this into a single logical path for you.
Because it's so necessary. I mean, when you look at those sources individually, they assume a massive amount of prerequisite knowledge.
Yeah, they really do.
It just looks like a wall of green text on a black screen to most beginners. But when you break down the actual mechanisms of how servers communicate, the whole process of deploying code becomes surprisingly intuitive.
Okay, let's unpack this, because you already know the internet is just computers talking to each other, right?
Exactly.
But the abstraction of the cloud makes us forget how physical it all actually is. I mean, if you want the world to see your code, it needs a physical destination, a place to live.
Real computer somewhere.
Right. And the sources point us immediately to the VPS, the virtual private server. So let's use an analogy to ground this.
I love a good analogy.
Think of the internet as this massive city, right? If you want to open a store, you need real estate. So a VPS is basically a rented flat in a highly secure, massive apartment complex.
That's a great way to look at it.
Yeah, and companies like DigitalOcean, AWS, or Vultr, they own the complex. When you rent a VPS, you get your own private flat, you get your own front door, which is your public IP address, and you get your own locks.
Right. And technically speaking, that apartment complex is a data center filled with bare metal hardware.
Huge racks of servers.
Exactly. A VPS relies on a piece of software called a hypervisor. And the hypervisor takes a massive, incredibly powerful physical server and just slices it up into smaller, isolated virtual machines.
Okay, so it's a slice.
Yeah, so your rented flat is a virtualized slice of shared infrastructure. It gets a dedicated portion of RAM, CPU, and storage, but it acts exactly like a standalone physical machine.
But I want to challenge the fundamental premise here.
Okay, go for it.
Why do I even need to rent a virtual slice of a server for like $4 or $5 a month?
Right.
I mean, I have a $2,000 laptop sitting right here on my desk. It has way more processing power than a cheap VPS. Why can't I just run my web application from my living room and let people connect directly to my house?
Well, it comes down to architecture and availability. Your laptop is designed for personal use, meaning it goes to sleep to save battery.
Oh, true.
Right. You close the lid, your Wi-Fi drops, or your residential internet service provider resets your dynamic IP address.
Which happens all the time.
Exactly. And the moment any of those things happen, your application goes offline. A VPS in a data center never sleeps.
It's always on.
Always. It operates with redundant power grids, industrial cooling, and fiber optic internet connections routed directly into the internet backbone.
Which means it basically guarantees your project is always available.
Precisely. And if we connect this to the bigger picture, by renting that $5 VPS, you are tapping into the exact same foundational architecture that powers the modern web.
Wow. So it's the real deal.
It is. You are getting the exact same root kernel access to a Linux environment that Fortune 500 companies use to scale their infrastructure.
Yeah.
It is a completely level playing field.
That's amazing. So, okay, and you pay your $5 and you get assigned an IP address. You've rented the flat.
Yep.
But the flat is, hundreds of miles away in a data center in Frankfurt or New York or somewhere. There is no monitor plugged into it, and there's no mouse. So to get inside and actually build your project, you need a remote control.
And that remote control is your terminal application. On a Mac or Linux machine, it's just called terminal. On Windows, it could be Windows Terminal or PowerShell.
And we really have to strip away the Hollywood hacker mystique of the terminal here.
Oh, definitely.
It is not a magical tool. Think of the terminal as a walkie-talkie connecting you to a very literal, somewhat stubborn assistant who is standing inside your empty, rented flat.
It's very literal.
Right. You cannot drag and drop files. You cannot click on things. You can only give this assistant specific text-based commands over the radio.
And the radio frequency you were using to transmit those commands is the SSH protocol, Secure Shell.
Right, SSH. Because it creates a secure, encrypted tunnel over the public internet between your laptop and your VPS.
Because without that encrypted tunnel, every command you type, every piece of source code you send, it would be transmitted in plain text.
Which is terrifying.
It is. Anyone monitoring the network traffic could just listen in on your walkie-talkie channel.
Okay, but the challenge with SSH is proving to the server that you are actually the person who rented the flat, right? Like,
Yeah.
how do you authenticate?
Yeah, that's the big question.
The traditional method is obviously a password, but the documentation from DigitalOcean and GitHub is incredibly firm on this point. They say using a password on a public-facing server is a massive security vulnerability.
Because the moment your VPS goes live, automated botnets constantly scan the entire internet for new IP addresses.
Just constantly roaming around.
Exactly. They will find your server's front door within minutes and start rattling the handle, just trying to guess the password over and over.
Yeah, and if you use a password, they will eventually brute force their way inside.
They will. That is why the industry standard is to abandon passwords entirely and use SSH keys.
Okay, SSH keys.
Specifically, the sources recommend modern cryptographic keys like ED2551 which uses elliptic curve cryptography, or RSA with a 4096-bit length.
What's fascinating here is the mechanism of asymmetric cryptography.
Oh, it's brilliant.
Yeah, SSH trust using keys is established without you ever typing a secret phrase. Instead, you generate a pair of cryptographic files on your local laptop, a public key and a private key.
Right, going back to our rented flat analogy, the public key is like a highly specialized padlock.
Okay.
You can email that padlock, text it, or mail it to the apartment manager. The server manager installs that padlock on your front door. In Linux, it's literally stored in a hidden file called authorized keys.
Inside the .sh folder, right?
Yep. And anyone can see the padlock. It contains no secret information, but the private key is the actual physical microscopic key that fits into that lock.
And the golden rule is that the private key never ever leaves your local laptop.
Never.
When you open your terminal and initiate an SSH connection to the server's IP address, the server looks at the public lock on the door and it generates a complex mathematical challenge.
Yeah, a math problem.
Right. It sends that challenge back to your laptop. Your computer uses your private key to solve the challenge behind the scenes, sends the solution back, and the server unlocks the door. The private key itself is never transmitted over the internet.
So an attacker listening in only sees a math problem and an answer, neither of which gives them the key to get in.
It's so smart.
And once you have your SSH key working, the sources emphasize locking the door permanently.
Yes, this is crucial.
You go into the server's SSH configuration file, the config file, and you change a line of text to completely disable password authentication.
You are effectively removing the keyhole from the door.
Exactly. It's the digital equivalent of breaking up the windows.
I love that.
The botnets can rattle the handle all they want, but the server won't even present them with a password prompt. It will only accept a connection if it detects the correct cryptographic signature.
And you also disable direct root logins in that same file, meaning nobody can log in straight off the internet as the ultimate super user.
Right, which dramatically reduces your attack surface at the protocol level.
So, your SSH key worked, the encryption tunnel is active, and you are standing inside your rented flat. But you have no visual interface.
Right, no monitor.
It is pitch black. This is where we have to learn how to speak Linux to our literal assistant over the walkie-talkie. We have to map out a dark room without our eyes.
And Linux structures data using the File System Hierarchy Standard, or FHS. Unlike Windows, which splits things into C drives and D drives, everything in Linux stems from a single root directory.
The slash.
Yes, represented by a single /. Everything user files, installed software, even attached hardware devices lives somewhere underneath that root slash.
So we need commands to perceive our environment. The sources provide a cheat sheet of essential commands. The first problem is spatial awareness. You drop into the terminal and you have no idea where you are.
You're completely blind.
Exactly. So the command for this is keywd wd print working directory.
And pwd queries the shell's environment variables and outputs your exact absolute path from the root. It will return something like /home/username.
It's like echolocation. You ask the assistant, where am I right now? And it tells you exactly which room you're standing in.
Exactly.
Once you know where you are, you need to know what is around you. For that, we use the command else-list.
Right. Else reads the contents of your current directory. But the basic else command only shows you the names of the visible files and folders.
Which isn't quite enough.
No. To truly understand what you're looking at, you need to add flags, specifically ls-lac.
Ah, yes. This is where the Linux Foundation's breakdown of file permissions becomes critical. The -L flag tells the assistant to show absolutely everything, including hidden files that start with a dot, like that .ash folder we mentioned earlier.
Right.
But the -L flag is where the real mechanism is.
Yeah, the -L flag outputs a long format. It doesn't just give you the file name. It outputs a string of characters that looks like DRWXR-X.
It looks like gibberish at first.
It does. But that string is the literal DNA of Linux security. It tells you exactly who is allowed to read, write, or execute that specific file. The first set of letters applies to the owner of the file, the second set applies to the user group, and the third set applies to everyone else on the system.
So by typing L's -law, you aren't just turning on the lights, you are inspecting the security tags on every single item in the room.
Exactly.
Once you see the layout you want to move around, you use CD, change directory. So CD/var/www tells the assistant to walk into the web sharing room.
Yep.
And if you want to walk backward out the door into the hallway, you type CD space ...
The double dot is a universal shorthand in Unix-like systems for the parent directory.
Good to know. And if you need to build a new room, you use empdir, make directory.
Simple enough.
But we have to talk about how you get rid of things, because the command for that is rrm, for remove. And this requires a massive shift in mindset for anyone coming from a standard desktop operating system. There is no recycle bin in the terminal.
None. There is no graphical interface protecting you from yourself here. When you execute an ARM command, the operating system doesn't move the file to a temporary holding area.
Like the trash can.
Right. It doesn't do that. It immediately unlinks the data structure that points to the physical location of your file on the hard drive.
Meaning the moment you hit enter, the assistant throws the item out the window and it disintegrates before it hits the ground.
Boom. Gone.
There is no "are you sure?" prompt by default. Gone means gone in a millisecond, so you have to treat WARM with intense respect.
Oh, absolutely. Which brings us to administrative tasks. When you first log in to a brand new VPS, you are looking at a system that was essentially frozen in time when the virtual machine image was created.
Right. And this is why we run apt update. The critique we got on earlier drafts of this topic compared apt update to washing your hands before you cook.
Yeah, I remember that.
But that only explains the concept of hygiene, right? It doesn't explain the mechanism. A better way to look at apt update is that you are updating your master contact book of suppliers.
Yes, that is a much more accurate representation. On Debian and Ubuntu-based Linux systems, apt is the package manager. It handles all software installations.
Okay.
But apt doesn't just search the internet blindly. It relies on a local database of software repositories. When you run apt update, you aren't actually updating the software on your server.
Wait, you aren't?
No, you are simply pinging the central Ubuntu servers and downloading the newest version of the Blueprint catalog.
Oh, okay. So you are making sure your assistant has the absolute latest phone numbers for the part suppliers before they start buying materials?
Exactly.
You want the newest blueprints so you don't accidentally install an outdated piece of software with known security vulnerability.
Right. And you will often find that when you try to run apt update, the server throws an error saying permission denied.
Because you are logged in as a regular user, and updating the master contact book affects the entire building.
Exactly.
To bypass that, you use my absolute favorite command, sudo, superuserdo. You type the exact same command, but put sudo in front of it. So, sudo apt update.
The mechanism of sudo is privilege escalation. It temporarily changes your user ID from your standard user to the root user ID, which is exactly 0 in Linux, just for the duration of that single command.
So it's pulling out a skeleton key that opens every door in the building.
Pretty much.
You only use it when you intentionally want to make a structural change to the system.
And this reinforces why we disabled direct root logins over SSH earlier. You want to navigate the system with a regular user account, so if you make a typo with that dangerous ARM command, the system will block you.
Right, built-in safety.
You only escalate your privileges with sudo when you are absolutely certain of what you are doing.
Okay, so the flat is mapped out, the contact book is updated, we have an empty room at /var/www. Now it's time to actually move the furniture in. We need to get our raw code from GitHub onto this physical server.
And to do that, we use Git. Git is the version control system that underlies GitHub. People often think of Git as just a way to download files, but its mechanism is much more sophisticated. Git doesn't save duplicate copies of your files every time you save.
What does it do?
It tracks deltas, microscopic differences and changes in the text of your code over time. GitHub is just the cloud platform that hosts that repository of deltas.
Okay, so Deploying your project is essentially handing your assistant an architectural blueprint that brings its own building materials.
Exactly.
You stand in your /var/www directory and you issue the command git clone followed by the URL of your GitHub repository.
And the Git clone reaches across the internet to GitHub servers, downloads the complete compressed history of all those deltas, and rebuilds the exact state of your code directly on your VPS.
But the sources emphasize a very specific syntax detail here.
Oh, the dot.
Yes, the dot. You type git clone URL and then add a single space and a dot at the very end of the command. Because if you omit that dot, Git will look at the blueprint, create a brand new subfolder named after your project, and build everything inside that nested folder.
Right. By appending the dot, you are explicitly modifying the destination path. The dot represents your current directory. You are telling Git, unpack the materials exactly where I am standing right now. Do not build a new room for them.
It prevents you from ending up with confusing nested folder structures that break your deployment paths later.
Which is a huge headache to fix.
Huge. So the raw materials are unpacked on the floor. Now we need the tools and the screws to assemble it. If we are deploying a standard Node.js application, we use our package manager to install the core tools. So sudo apt install node.js npm.
Yep.
But then we have to run another command npm install inside our project folder. What is the actual mechanism happening there?
Well, modern software is almost never written from scratch. It relies on a massive supply chain of open source libraries and dependencies. In a Node project, that entire supply chain is documented in a single file called package.json.
Okay.
When you run npm install, the Node package manager reads that file, parses the dependency tree, reaches out to the central npm registry, and downloads the exact versions of the external libraries required to make your code run.
So you downloaded the custom blueprints from GitHub, and you downloaded the standard screws and bolts from npm. The project is assembled.
Ready to go.
You type node-index.js. The terminal outputs server running on port 3000. Your code is live. You open a web browser on your laptop, type in your VPS's IP address, and there it is. Your website is on the internet. You did it.
It is a massive milestone for any developer.
It really is. So you smile, you proudly close your laptop lid, and you go to make a coffee. But the second your laptop clicks shut, your website instantly dies.
Yep, offline.
It goes completely offline. Why does closing my laptop kill a program running on a server hundreds of miles away?
Because it has to do with how the Linux kernel handles processes. When you type node-index.js, that process is mathematically bound to your active SSH session.
To my walkie-talkie channel.
Exactly. It's called your TTY, or teletypewriter interface. You are essentially holding the walkie-talkie button down to supply power to the app.
So when I close the laptop lid,
Your Wi-Fi drops, and the SSH connection is severed. When the server detects that the connection is gone, it sends a signal called signal hang up to every program attached to that session.
oh wow.
SIGUP violently terminates the processes. The operating system assumes that since the user left, the programs they were running in the foreground should be cleaned up to free up memory.
The assistant realized you hung up the radio, so they just dropped the furniture and walked away.
Exactly.
We need a way to tell the server to keep the application running independently of our SSH session. And here's where it gets really interesting, because that is where PM2 comes in.
PM2 is a production process manager for Node.js. You install it on the server, and instead of executing the code yourself, you delegate the execution to PM2. You type PM2 start index.js.
It's the equivalent of hiring a 24/7 butler for your rented flat. You hand the app to the butler and say, hold this, and whatever you do, do not drop it.
Right.
And once the butler takes it, you can safely hang up the walkie-talkie and close your laptop. The app stays live.
Because the mechanism PM2 uses is called daemonization. A daemon, which stands for disk and execution monitor, is a process that intentionally detaches itself from any user session and runs continuously in the background of the operating system.
Okay, that makes sense.
But PM2 doesn't just run the code, it actively monitors the process ID.
Wait, let me push back on this though, because PM2 has a feature where it automatically restarts the application if it crashes.
It does.
If I write a terrible piece of code that causes a fatal memory leak at 3:00 a.m., PM2 will instantly catch it and restart the app. Aren't we just sweeping garbage under the rug?
I see what you mean.
Like, aren't we hiding a fatal bug in an infinite loop of crashing and restarting instead of actually fixing the code?
It's a valid concern. If your app is crash looping every 5 seconds, PM2 will eventually implement a backup strategy and stop trying to prevent the server CPU from catching fire.
Okay, good.
But the value of the auto restart isn't to ignore bugs, It's to maintain uptime while you sleep. PM2 logs every single error output to a specific file, so your users experience a brief hiccup instead of a permanent outage. And when you wake up, you can review the logs, identify the memory leak, and push a fix. It's about resilience.
Got it. It's a safety net. And there is one more vulnerability to account for. What happens if the data center loses power or the virtual machine has to reboot for a kernel update?
Right, the whole machine restarts.
The SSH session isn't the problem anymore. The entire operating system just went down. When it turns back on, the butler is asleep.
To solve this, the sources highlight two commands, PM2 startup and PM2 save. PM2 startup generates a custom script that hooks directly into the core Linux boot sequence, usually a system called systemed. And PM2 save freezes your current list of running applications into a manifest file.
So the implication is that as soon as the server receives power and the operating system initializes, it reads that system script, wakes up the butler, hands them the manifest file, and the butler immediately spins your website back up before you even realize the server rebooted.
Exactly. It turns a fragile, temporary script running in a terminal into a robust, resilient system service.
Which brings us to the end of the deployment path. Look at the mechanisms we uncovered today.
It's quite a list.
You stripped away the cloud abstraction and rented a slice of bare metal hardware. You secured the front door by replacing passwords with an asymmetric cryptographic lock. You used a secure walkie-talkie to navigate the file system with echolocation.
Yep.
You updated your package manager's blueprint catalog. You downloaded the exact deltas of your code from GitHub. You fetched your dependencies. And you demonized the process so it runs independently of your laptop.
When you break down the WHY and the HIW behind every command, you realize the command line isn't an archaic way of using a computer. It is an incredibly precise vocabulary for managing infrastructure.
And once you possess that vocabulary, you have the absolute power to deploy your ideas to the world. But resolving this single deployment, this raises an important question.
It does, because we just perfectly configured one app on one server.
Right. What happens when your application goes viral overnight? What happens when one rented flat simply does not have the CPU or RAM to handle 10,000 simultaneous users, and suddenly you need to deploy your code across 100 servers all at once, perfectly synchronized?
Yeah.
You can't manually SSH into 100 different machines and type git clone over and over again.
Definitely not.
You can't just hire 100 butlers. You need a system to command the army of butlers.
Right.
And that is where you leave the single VPS behind and you step into the world of Docker containers, which replicate your environment perfectly, and Kubernetes, which orchestrates the chaos across entire data centers. But that is a deep dive for another day.